right, welcome, okay, to the unit circle lesson. All right, we're gonna pick up where we left off during block 1, which we figure out how to do quadrant 1. Okay, we look back at our special right triangles, okay, and we're able to narrow down the unit circle and figure out all of quadrant 1. What you're looking at right now is a complete unit circle, all right, has everything in it, all 4 quadrants, which we're going to do together. Right, today, and it has these extra pieces in it, okay, that we did not talk about during block 1. These are called radians. This is a second way to define an angle. Instead of just always using a degree measurement, okay, we can measure in something called radians. We're going to talk about that. It's related to the arc length and so forth. So we're going to get through the whole unit circle today. We're going to get through how it relates to sine and cosine. We're going to and then talk about radians. So a lot going to go on today. All right, so what we want to do first is we want to fill in the whole unit circle here, okay, based on what we do know. All right, and so what we know, okay, are the degrees. So let's fill in the degrees. Okay, so you can see here that we have 0 degrees, and we know that this is going to be 30 degrees. So it's kind of sloppy here. Let's see if I can change this back. 30 degrees. Let's get 0 degrees here, 30 degrees, 45 degrees, 60 degrees, 90 degrees. Okay, and then we just keep going. We know there's a 30-degree gap here, so another 30 gives me at 120. Okay, and then a 15-degree gap gives me at 135. Okay, and then we know there's a 30-degree gap here, that's 150, or you can just add 15 again. Here's 180, right? And again, so now 210, 225, 240, 270. And then we're over here at 300, 315, 330, and we end at 360 again. Okay, so just going around, we know there's always a 30-degree difference. Okay, in the first one, all right, and then in between it's 15 degrees. All right, so now we got to fill in our coordinate points. All right, and so on block 1, we learned how to do the first quadrant. Okay, and so again, we have this 30, 60, 90 triangle here. The radius is 1. Okay, so opposite of 30 is going to be 1/2, so we're going 1/2 up. Okay, and then the other one is rad 3 over 2, because it's just that side times rad 3. Okay, for a 45 degree triangle, if the hypotenuse is 2, okay, then both the other sides are rad 2 over 2. And then for my 60-degree angle here, again, it's just the same thing as the 30, 60, 90 triangle, but it's just flipped here. So we got the short side is 1/2, and then the longer side is rad 3 over 2. All right, and then we obviously know that this point is 1, 0, because the radius is 1. Okay, which means that this point up here will be the point 0, 1. Okay, all these little dashes here are for radians. Like I mentioned at the beginning of the video, we're going to fill that in later. Okay, so if we have the first quadrant done, okay, we should be able to easily figure out the rest of the circle. The key is, can you figure out that first quadrant? And just using our special right triangles, okay, we should be able to figure that out. Okay, but what else do we know? Well, for sure we know, okay, this point here is -1, 0, and then this point down here, okay, which is kind of off the screen here, is going to be the point 0, -1. Write it in there for ourselves, 0, -1. All right, so we definitely know, obviously, those key points there. Now let's figure out the rest. All right, and so These spots they're going to correspond over here. All right, so this degree right here, it's the same triangle over here going the other direction. So this point over here will be the same values, but my x coordinates are all negative. So it's going to be negative rad 3 over 2, 1/2. Okay, and then same thing with this one here, it's negative rad 2 over 2, positive rad 2 over 2. And then over here, negative 1/2, positive rad 3 over 2. All right, down in the third quadrant, both the x and y's are going to be negative. Okay, so this will be negative rad 3 over 2, negative 1/2. Negative rad 2 over 2, negative rad 2 over 2. And then down here, negative 1/2, negative rad 3 over 2. Okay, and then fourth quadrant, the x's are positive and the y's are negative. Okay, so we're going to get rad 3 over 2, negative 1/2. All right, and then we're going to get rad 2 over 2, negative rad 2 over 2. And then matches up here, we're going to get 1/2, negative rad 3 over 2. So notice, right, these kind of just color code this here. It's one triangle, right? This line, this triangle right here, it's going to be the same, right, for all these. That blue triangle there, that's why the x and y coordinates are the same for all of them there. And then match up the 45-degree triangles, match up the 60-30 triangles. The points always line up. The x, y coordinate points always line up. It's just the positive, negative signs depend on what quadrant of the unit circle you're in. So again, that's why it's so important to understand the first quadrant, because if you can fill in the first quadrant, then you can complete the rest of the circle. All right, and then if we go ahead and look at the next one, clear all my work here. So now watch this shortcut. All right, so let's see, is there a shortcut I can use? All right, so obviously we know a couple points. We got 1, 0, we got 0, 1. Okay, and if I really fast, if I just, I'm not going to do the whole circle again. I'm just going to do the first quadrant here. You know, if I just write 1, 2, 3, and then back down 1, 2, 3, the denominator for everything is going to be 2. And then on the top, so you get radicals. Anyone that's not a 1 gets a radical. And I've got the first quadrant filled in. Again, all I did was went 1, 2, 3 along the outside, then back down 1, 2, 3 along the inside. Okay, the denominator is 2 for everything. Put radicals on top, okay, for any number that's not 1. All right, and then you have the whole first quadrant done, and then you just match up with the corresponding angles in the other quadrants and just make sure your signs are good. Remember, your signs in quadrant 2, they're always negative, positive, and then in quadrant 3, it's negative, negative, and in quadrant 4, it's positive, negative. And obviously, quadrant 1 is positive, positive. All right, but once you can figure out quadrant 1, okay, the other quadrants just correspond with it. So again, the shortcut, all right, instead of using the 30, 60, 90 properties of a triangle, start on the outside, you go 1, 2, 3, all right, and then let me clear, I'll do it again so you guys can see how fast it actually is. So I clear my work. All right, so again, this is 1, 0, this is 0, 1. Okay, you just kind of go starting there, 1, 2, 3, back down, 1, 2, 3, and I could just put a square root around all those numbers that are not 1, and then the bottom you get 2 everywhere on the bottom. Now that whole first quadrant is completed. that quickly, and then I can just match it up. All right, so for example, if I wanted to do quadrant 3, right, it's going to match up, but there's going to be negatives. Negative rad 3 over 2, negative 1/2. Negative rad 2 over 2, negative rad 2 over 2, negative 1/2, negative rad 3 over 2. So it just kind of matches up, okay, with the correct quadrant. Okay, that's our shortcut. All right. On there. All right, so now we want to connect, okay, this to trig, all right, our sine and our cosine. All right, so what is the sine of 30 degrees? What's the cosine of 30 degrees? Okay, what's the sine of 45? What's the cosine of 45? And same with 60 degrees. All right, so that's going to be our SOHCAHTOA. All right, so we have these triangles here. From yesterday, if we have a 30, 60, 90 triangle, okay, with a hypotenuse of 4, we know that the side opposite of 30 is going to be half the hypotenuse, and then this would be 2 rad 3. All right, and so if I ask you, okay, what is the cosine of 30 degrees? All right, we are going to do adjacent over hypotenuse, 2 rad 3 over 4. So that is going to reduce down to rad 3 over 2. I ask you what the sine of 30 degrees is. That's opposite over hypotenuse, so that's 2 over 4, which reduces down to just 1/2. Right, so I get sine of 30 degrees is 1/2. I get cosine of 30 degrees is rad 3 over 2. All right, and so what I want you guys to start thinking about is, do those numbers look familiar? Do those look like something we just saw as we created the unit circle? All right, now let's do the same thing for 45 degrees. Okay, so we know that for a 45, okay, degree triangle, if the hypotenuse is 4, we know that these have to be the same, right? These are x, right? And so when you do this, okay, if you wanted to solve for x here, you're going to get 2x squared, right, equals 16. X squared equals 8. So you square root that, x equals 2 rad 2. So each side is 2 rad 2. All right, so with that being said, okay, let's get some room to work here. Cosine of 45 degrees. Okay, adjacent over hypotenuse, that's 2 rad 2 over 4, just reduces to rad 2 over 2. And sine of 45 degrees, opposite over hypotenuse, it's the same thing, 2 rad 2 over 4, which reduces to rad 2 over 2. All right, so we have our answers here. Okay, cosine of 45 degrees is rad 2 over 2. Sine of 45 degrees is rad 2 over 2. Again, I want you to start thinking about, do I see those on the unit circle somewhere? All right. Coming back up to this first one, I could do 60 degrees as well. Let me clear my work here. All right, so that was 2, that was 2 rad 3. So if I do cosine of 60 degrees, all right, adjacent over hypotenuse, that's 2 over 4, which is just 1/2. If I do sine of 60 degrees, which is supposed to be degrees, looks like 600. Sine of 60 degrees, that's opposite, that's 2 rad 3 over 4, reduces to rad 3 over 2. Okay, so cosine of 60 degrees is 1/2, sine of 60 degrees is rad 3 over 2. Again, do those numbers look familiar to the unit circle? All right. All right, so same idea here. Now the hypotenuse is 2. So what are we going to get here? Okay, so here, the side opposite 30 is 1. The side opposite of 60 is rad 3. So if I do cosine of 30 degrees, let's start with 30 degrees. Okay, that is rad 3 over 2. I do sine of 30 degrees. That's opposite over hypotenuse, that's 1/2. And if I do cosine of 60 degrees, adjacent over hypotenuse, that's 1/2. If I do sine of 60 degrees, that's opposite over hypotenuse, that's rad 3 over 2. All right, so for my 45, again, this will be rad 2. This will be rad 2. So if I go cosine of 45 degrees, I get rad 2 over 2. I do sine of 45 degrees. I also get rad 2 over 2. And yeah, I'm looking at these numbers. I'm seeing the same numbers over and over again. I'm seeing rad 3 over 2. I'm seeing 1/2. I'm seeing rad 2 over 2. All right, those should look very familiar to the unit circle. We just got to figure out where on the unit circle they are going and coming from. So now, I'm actually going to do it with the triangles that have a hypotenuse of 1. All right, and so when I fill this out, right, I get half of 1 is 1/2, right, and then over here, it's rad 3 over 2. All right, and so when I do cosine of 30 degrees, right, since the hypotenuse is 1, it's always just over, so it's just 1/2. It's 1/2 over 1, which I don't need to write, right? So, and if I do sine of 30 degrees, I'm sorry, my bad. I did that backwards. Let me erase that. Cosine is adjacent over hypotenuse, so that's rad 3 over 2. Okay, adjacent, and then sine is opposite over hypotenuse, so sine 30 degrees is 1/2. All right, if I go cosine 60 degrees, now that's adjacent over hypotenuse, so that's 1/2. Sine of 60 degrees, that's opposite over hypotenuse, so that's rad 3 over 2. All right, if we go to a 45 triangle, and the hypotenuse is 1, that's rad 2 over 2, and that's rad 2 over 2. So cosine of 45 degrees, adjacent over hypotenuse is rad 2 over 2, and sine of 45 degrees is also rad 2 over 2. All right, so on all 3 of the last slides, okay, sine of 30 degrees was always 1/2. Okay, cosine of 30 degrees was always rad 3 over 2. Right, cosine of 60 degrees was always 1/2. Sine of 60 degrees was always rad 3 over 2. Cosine of 45 degrees and sine of 45 degrees was always rad 2 over 2. So they never changed. All right, and so where do we see this on the unit circle, okay, in comparison, okay, to the X and Y coordinate points. All right, so let's take a look. And match these up based off of our work that we just did. All right, so if I asked you, okay, cosine of 30 degrees, okay, every single time, that was rad 3 over 2. Right? If I asked you cosine of 60 degrees, every single time, that was 1/2. And then cosine of 45 degrees, every single time, that was rad 2 over 2. And then for the sines, right, if I said sine of 30, okay, sine of 30 every single time was 1/2. Okay, if I said sine of 45 every single time, that was rad 2 over 2. And sine 60 was always rad 3 over 2, every time. All right, so now that we know that, okay, use a text box to explain the connection between the coordinates x, y, the unit circle at the different degrees. All right, and so if I asked you, right, I just did ask you, okay, if I asked you cosine of 30 degrees, every single time on the last few slides, it was rad 3 over 2. Okay, if I asked you what sine of 30 degrees was, it was always 1/2. Okay, and if I asked you cosine of 45 degrees, it was rad 2 over 2. Sine of 45 degrees was also rad 2 over 2. And then cosine of 60 degrees every single time was 1/2. And sine of 60 degrees every single time was rad 3 over 2. All right, so when we look at the 30 degrees, right, the x value was rad 3 over 2, the y value was 1/2. Okay, so the sine of 30 was 1/2. That was my y value, right? And cosine 30, that was my x value. Well, with the 45 degrees, it's kind of tricky because they're both the same. Okay, but let's look down at 60 degrees. Cosine of 60 degrees is 1/2. That's my x value. Right? Sine of 60 degrees, rad 3 over 2. That's my y value. Okay, so the connection that I want you guys to see here is that the cosine of an angle is the x value on the unit circle. Sine of the angle is the y value. So what I want you guys to type in here, okay, is that cosine of theta equals x. Okay, what x am I talking about? I'm talking about the x coordinate on the unit circle. Theta is just any angle measurement. Okay, and sine theta, again, any angle measurement is always y. So if I asked you what cosine of 0 degrees is, cosine of 0 degrees, okay, cosine is the x value. What's the x value? That's 1. Cosine of 0 is 1. And if I asked you what sine of 0 degrees is, sine is the y value, that'll be 0. All right, so our unit circle will give us, all right, some trig values, okay, of certain degrees, the very common degrees that we see a lot, which are the 30, 45, 60, okay, degree increments along, okay, the unit circle there. All right, so that's a very important connection there, okay, make sure you get that down. All right, so now we're going to introduce a new way to measure an angle. So the only thing that you've ever learned in geometry, okay, is degrees, right? We measure an angle in degrees, okay? But just like you can measure something, the length of something in inches, feet, yards, meters, right? There's another way to measure an angle, all right? And so you know degrees, and what we're going to learn today, it's called radians, okay? What is a radian, okay? The definition of a radian is the length of the arc, okay, above the angle divided by the radius of the circle. All right, and so we have an angle measurement theta here, okay? We could give that a degree measurement, or we could find its value in relation to the arc length, okay, and the radius. So it's the ratio of the arc length to the radius, okay? And that number is going to be the measurement of the angle in radians. So instead of saying 30 degrees, okay, you'll say a number radians, okay? And since arc length always has pi in it, okay, remember the circumference is 2 pi r, okay? So if we really fast, right, some geometry here, circumference of a circle is 2 pi r, all right? And so the arc length of the whole circle is the circumference is kind of saying that, right? And when you divide it into portions, you've got to divide the portion, okay, by your degree measurement, okay, by the portion of the circle. So like 30 degrees, right, is what part of the circle, right? It's 30 over 360, okay, that's 1/12 of the circle. All right, and so what would the arc length be? You would just divide the circumference by 12 there to get the arc length of 30 degrees. All right, so that's just some review there from geometry. All right, so filling in radians. Okay, so we filled this in quite a bit here. So let's just talk about some of the things that we do know. Okay, 0 degrees. Okay, if we just fill in all the degrees really fast again. $225, $240, $270, $300, $315, $330. We always end at $360. All right, so we have the degrees put in. Okay, we know some points. Let's put all. We know all the points, but we'll just label these along that actually hit the x and y axis here. I mean, this one's kind of off the chart here, but put it in there. Okay. So now the unicircle, remember, has a radius of 1. All right. So what we want to do is we want to put the radians in along the best that we can. And what do we know? All right. So what do we know? We know that the circumference of this circle is 2 pi units. We don't. All right. Units. We don't know just a unit right now. It could be centimeters. It could be whatever. It's 2 pi because the radius is 1. So 2 pi r is 1. So the circumference of this circle here is 2 pi. All right. And so a radian, okay, is, so theta, okay, an angle measurement, okay, is the arc length, okay, divided by the radius. So in this case, for all the way around the circle, okay, the arc length is 2 pi, the radius, so theta equals 2 pi here, 2 pi radians, okay. So right here, 360 degrees is the same as 2 pi radians. And you don't have to write rad every time, okay? We know that it's going to be in radians. So you can just write 2 pi right here, okay? But you abbreviate it rad when you're writing it out. And so what other ones must we know? Well, if the whole circle is 2 pi, right, then obviously this is going to be 0 pi or 0 radians. Right, but what's halfway then? Well, you just divide 2 pi by 2 and you get pi. So this is pi radians. Okay. Divide that in half, you end up at 90 degrees. So pi over 2 would be the same as 90 degrees. All right, what about another half? So half of 90 degrees is 45 degrees. Half of pi halves is pi fourths. All right, and so knowing that every 45 degrees is pi fourths, right? Pi fourths, 2 pi fourths. This one's going to be 3 pi fourths. This is 4 pi fourths, which reduces to pi. Okay, this will be 5 pi fourths. All right, this will be 6 pi fourths or 3 pi halves. All right, this will be 7 pi fourths. And then 8 pi fourths, which reduces to 2 pi. So we have quite a bit filled in, okay? Now we kind of have to figure out what 30 degrees is, okay? Well, 30 degrees is 1/12 of the whole circle, all right? So if the whole circle is 2 pi, right, what's 1/12 times 2 pi, right? And so that's going to be 2 pi over 12, which reduces down to pi 6. So 30 degrees, okay, is the same as pi over 6. So every 30 degrees is pi over 6. So this will be 2 pi 6, which reduces to pi thirds. Okay, 3 pi 6, which is 1/2. 4 pi 6, which is 2 pi thirds. 5 pi 6. 6 pi 6, 7 pi 6, 8 pi 6, which reduces to 4 pi thirds, okay, 9 pi 6, okay, 10 pi 6, 5 pi thirds, 11 pi 6, and then 12 pi 6, which is 2 pi. So we have figured out the whole unit circle, okay, all derived from knowing that a full circle is 360 degrees. If the radius is 1, that arc length is 2 pi. So 360 degrees must equal 2 pi. So that means 180 degrees must equal pi. We kind of just reduced it all the way down. Getting 30 degrees was kind of tricky. We had to know that 30 degrees is 1/12 of the whole circle. So the radian would be 1/12 of the whole circle. So 1/12 of 2 pi is pi 6. And we just every 30 degrees is pi 6. So we go pi 6, 2 pi 6, 3 pi 6, 4 pi 6. Every 30 degrees, but then you just reduce them. Right? So like when you get to 3 pi 6, right, that reduces to pi halves. So that's what we end up getting there. All right, so we're going to kind of give you a shortcut way to always convert degrees to radians, okay, here on the next slide or two. All right, so here is the easy, okay, shortcut way to convert both directions, okay? So if I give you degrees, okay, and you want to convert it to radians, you just simply multiply the degrees by pi over 180, okay? So for example, the one that we just did, if I want to change 30 degrees, okay, into radians, I multiply 30 degrees by pi over 180. Right? And so 30 goes into 180 6 times. So it's just pi over 6. Obviously, the degrees cancel. The units cancel out. So it becomes radians. Pi 6 radians. All right. And to convert radians to degrees, you multiply radians by 180 degrees over pi. So let's just double check that. So if I have pi 6, okay, I need to multiply it by 180. Pi, the pi's cancel out. 180 degrees divided by 6 is 30 degrees. So going both ways, you see that it works. All right. Went too far. So here's two more examples. Okay, so 45 degrees, you go 45 times pi over 180. 45 pi over 180, which reduces to pi fourths. All right, and then if I give you 5 pi, what's 5 pi in degrees? You get 5 pi times 180 over pi. The pi's cancel out. 5 times 180 is 900, so it's 900 degrees. That means you're going around the circle, okay, more than once. In that case, more than 2 times as well. All right, and so that's going to correspond with another degree anyways. All right, that we know that's on the unit circle. All right. Okay, so you guys are going to take a second to convert these to radians. So every single time, what do you have to multiply by? All right, and so you're going to want to multiply by pi over 180 every time. All right, because you want the degrees to cancel out. That's how you know to put the 180 degrees on bottom, so the degrees cancel out. All right, so 60 over 180, that's going to be 1/3. That's just pi thirds radians. And again, you just put RAD for radians. All right, so again, all these are times pi over 180. All right, so that'll be pi 6. All right, if it's negative, just means you're starting with a negative degree. Okay, that just means that along the unit circle, you're going the other direction. Right, going counterclockwise is positive, going clockwise is negative. All right, and so negative 54 degrees, right? You're just going down 54 degrees. You're going to end up in the 4th quadrant. Not important right now, but again, you just multiply that by pi over 180, okay, and then simplify that fraction, right? So you're going to get negative 54 pi over 180, okay? And so let's see, 9 goes into both, something else there does too. But we reduce both of those by 9. You're going to get 6 pi over 20. And that's going to reduce, 2 goes into both of those. And get 3 pi over 10. All right, and so you guys can do the last 2 there on your own. And now when you want to convert, okay, radians to degrees, okay, now I want degrees to be in my final answer, so now I've got to multiply by 180 degrees over pi, because now I want the pi's to cancel out, so the pi's got to be on bottom, and then that's just 30 degrees, all right, 180 over pi, pi's cancel out, that's 90 degrees. Again, negative just means you're going to get a negative degree here. So times 180 over pi. The pi's cancel out. Okay. 18 goes into that 10 times. Okay, so you're going to get negative 11 times 10, so negative 110 degrees. And you can do the last one there on your own. All right, so that is our lesson. I think there's one more slide here. Okay, so if sine 45 degrees is rad 2 over 2, what does sine pi fourths equal? All right, well, rad 45 degrees, okay, if I multiply that by pi over 180, okay, those cancel out, okay, and I get pi over 4. So 45 degrees is the same as pi over 4 radians. So sine of 45 degrees is going to equal sine of pi fourths. So therefore, they both, okay, are rad 2 over 2. So that's our lesson for today.